One very cool addition to Action that I'd like to show you is the arrival of a new type of Gmask node that we've actually decided to integrate directly inside of Action. There's a it was a very conscious decision to actually decide to put something directly inside of Action, again, because our intention was to provide very in-context tools to create transparency effects at the scene level inside of Action as opposed to the media level. And the other thing that was very interesting for us with this is to, again, exploit the fact that since we have a 3D environment, what would become of something like a transparency region, a Gmask, that would exist inside of 3D space and therefore also kind of obey the perspective and an axis transformation in 3D to generate its transparency effects. So that cumulated with 3D tracking opened up a couple of really interesting capabilities that I'll get back to a bit later. But just to start with the Gmask object. So in the object bin, you will see that now you have a new Gmask object here. To use it, well, essentially you just double-click it to add it to the scene, and what you will see is that you have a cursor that now allows you to start drawing a Gmask directly inside of Action. So if I close it, well, you see that instantly what has happened, it has actually generated a transparency hole inside of the scene. This is actually not exactly the same Gmask that you know instead of the Gmask node of batch. It's a new and improved Gmask. To start with, if I look at some of the things that I can do with it, for example, the way that I can handle a transparency gradient is I switch to additive mode, hold the Shift key, and just drag a transparency gradient out of the inner spline. If I want to have an internal gradient, I just, again, Shift add and drag it internally. If I want to have different thickness of my external gradient, well, I just add extra points and drag them out until I'm happy with what I'm getting. So it's a much more flexible way of dealing with gradients than you were accustomed to with advanced gradients in the old keyer, because again, the vertices that actually control the shape of the spline are no longer correlated to the vertices that control the thickness of the gradient. So that's kind of cool. The other thing, again, is that again, this is something, my Gmask object in my schematic here actually lives inside of 3D space. So if I decide to move its axis around, it's actually going to generate a transparency effect on everything that intersects with it. If I start also rotating it, it actually also changes the transparency effect as I do this. Now, of course, if what I want to achieve is the exact opposite, which is essentially have a transparency effect outside, I just need to double-click to get the interface of the Gmask and hit invert. And at this point, the gradient of transparency and the transparency effect gets applied outside of the Gmask. Now, there were some debates about whether or not we should leave it as a transparency inside of the object or outside of the object. So this is a friendly warning. Maybe you will be taken aback. We finally decided to, by default, create the transparency effect inside of the spline, which is somewhat different from what happens with a regular Gmask. But of course, it's just one click away. If you're not happy with it, just click invert, and it will be something that is probably, in some instances, perhaps more familiar. But the reason for us not implementing this by default is that we thought it would be kind of awkward to have the entire scene disappear the minute that you would close the Gmask. Another interesting thing to point out is that the Gmask can also exist as an open spline. And as you see here, I'm kind of creating this spline sausage with a transparency effect, and it's still keeping its transparency effect even though it is an open spline. So this new Gmask actually supports the notion of open splines, which makes it also very flexible. Again, if I want to close it again, I just click close, and it will close the shape. Now, of course, at this point, it's a bit screwed up, but you get the picture. Now, the one thing that I also want to show you about this new Gmask is that, so by default, it will, if it's not parented to any specific object, it will by default affect the entire scene. But the really cool thing is that I can actually assign the Gmask to affect a specific object. And this is kind of similar, I guess, to to what you have with lights, where you can say a light should only light a specific object. Well, in my schematic, I can actually get my Gmask to only affect a specific object, or a series of specific objects. And the way that I would do this is that in the list of modes that I have here, I now have a new mode which is called Gmask. And the hotkey is Alt-G. And what I can do is actually then drag a connection with the object that I want to affect with my Gmask. And at this point, when I switch back to the perspective view, what you will see is that only the 3D text that I've parented the object to gets affected by the Gmask. And again, because this is a Gmask that exists in 3D space, if I move it here on the side and I start orbiting my camera around, you will see that as it intersects with the objects, it makes it disappear. So this is something that is actually extremely useful to simulate occlusions within a 2D image. And again, cumulated with a 3D tracking, provides you with instant occlusion tools to do instant occlusion faking within a 2D image while remaining consistent with the perspective inside of your shot. It's a very powerful feature. So we didn't stop at that. There's a whole bunch of improvements to the Gmask that we also did. So for example, one of the things that we implemented with this Gmask is its ability, for example, to have localized transforms. So if I go to the Vertex menu here, you will see that not only am I able to actually do a translation, but I can also do a rotation, for example, of this particular selection. And here, as you see, I have my rotation center, and if I move it around, I can go ahead and do a rotation of my vertices around this point. I can also do a scaling, and this will be performed again relatively to the scaling center. If I move it around, there you go, the scaling will be done accordingly. This is the transformation and the effect of the pivot is only valid at the time where you actually perform the transformation. We also actually have added a number of things where you can have the center of scaling and rotation be automatically detected based on the selection. So if you select centroid, it's going to determine what is, for example, the center of gravity of your selection and locate the point based on that. So a lot of things to play with. Again, in terms of interaction. So there's a lot of cool improvements that we've done, but the other thing that I want to show you is that we went one step further and also went as far as implemented shape tracking into the Gmask. So here I have this shot of a singer on a green screen, and let's say that I'm going to bring up the node bin and add a Gmask. Double click, and let's go ahead and do something like this around his shirt. Okay, and I'm just going to extend the tangents here. And again, if you double click on the Gmask, now you notice first of all that if I had the image selected before it, the Gmask got instantly parented to it, which means that it will move. This is just a hierarchy parenting. It doesn't mean that the Gmask will only affect a specific layer. It means that it will move like this particular layer. But it will affect all objects in the scene until I actually do an Alt-G link, the blue link that I showed you earlier on. But so, in the mask menu, in the Gmask menu, you will see that there is a tracking submenu here, and it actually provides me access, first of all, with the regular tracker that you already know, which allows you to track vertices, but also the axis. But we also have the shape tracker here, which is, again, which is inspired by the luster shape tracker. On the controls for the shape tracker, you can actually decide how many trackers and the size of the trackers expressed in pixels that you would want to actually see being used within the region that is defined by your Gmask. I can decide if I want to track forward, backward. I can actually also interrupt the tracking at any point in time and resume it. But let's see what happens. So I've just added here a number of trackers. I do shape track, and it's going to try and figure out what the hell's happening with the movement of the singer. As you see, as the guitar moves in, it does its best to ignore the temporary occlusion to stay put on the actual singer. So it was as simple as that. It is fair to mention that the number of trackers and the size of the trackers is something that can have an impact. So if I redid this tracker, let's say, this tracking, let's say perhaps with a lesser amount of trackers, I can go ahead and do it again. And there's a chance that perhaps the tracking will not be identical or not as good. Well, actually, you see I had a problem here. The occlusion was not handled in the same way. I can backtrack at any point in time where the problem actually happens, change the settings to something higher, and resume the tracking. It's pretty flexible. So sometimes there can be a little bit of trial and error, but that gives you essentially the idea around the Gmask.